So when we solve an inequality, it's just like solving an equation. But if you have to take a step to multiply or divide both sides of the inequality by a negative, then you've got to flip the inequality symbol. And one anecdotal reason for that is if you have negative 2, negative 20, that's actually less than negative 2, right? So when you go in the negative worlds, bigger digits mean smaller. So if you're flipping from one world to the other, then you've got to flip the inequality symbol too. Okay, but no flipping here. Even though this is a negative 1, I have to take the step of multiplying both sides by a positive 5. So I'm not going to flip the inequality here. Still got to multiply both sides. So I cut out the legs of that fraction, and then I've got negative 5 over here. And the rest is pretty straightforward, right? Add the 2. I'm not multiplying or dividing a negative, so no changing signs. Divide both sides by 3, so this is my solution. X is greater than negative 1. In an inequality notation, we got this right here. In the interval notation, though, you say the smallest, comma, largest. So if x is bigger than negative 1, then the smallest we can get to is infinitely close but never touching negative 1. So that's why I use the parentheses. And the largest we can be is positive infinity. And remember, we always use a parentheses next to infinity because you never reach infinity, right? Okay, so there's that solution. Here, this is a compound inequality. I'm going to multiply both sides of the compound inequality by 4. So that's going to give me 4 is greater than 3y minus 1, which is greater than negative 4. And I'm going to add 1 to all the sides of the inequality. So that's 5 is greater than 3y, which is greater than negative 3. And then the last step, that's 3 times y. So we want to divide 3 from both sides. So 5/3 is greater than y, which is greater than negative 1. Or equivalently, this is more conventionally to go least from greatest. You can switch it like this. Notice that I'm keeping the inequality symbols pointing in the same direction. So this is the right answer. And in interval notation, that's negative 1 to 5/3. Okay, so that's that one. This one here, ooh, it's even easier, huh? Add 1 to both sides, so get negative 5 less than 5t, which is less than 1. Then divide 5 from both sides, so you get negative 1 is less than t, which is less than 1/5. I don't know why this one came after this one. This one's harder. Whatever. Okay, so this one here, similar to a problem that we've seen before, we want to get the legs out of the fractions. I'm going to multiply by the least common multiple of the denominator, something that both 2 and 3 can fit into. 2 fits into 6 evenly with division, 3 fits into 6 evenly. Okay, so when I do that, you cross cancel here, but dividing this by 2 and this by 2. So that means I have a 3 that needs to be left over to multiply to the numerator. Cross cancel, yeah, we're done with that 3. Cross cancel, so we got a 2 left over to multiply to this numerator. And the big thing students forget is to multiply that 6 to a non-fraction number. Every term has to be multiplied by 6. And now we can distribute. We can combine the negative 3x and the 10x. That makes 7x. So 9 minus 4 makes 5. Negative 3x plus 10x makes 7x. Subtract that 5 from both sides. And then divide 7 from both sides. Oops. Okay, and I think that's it. So in interval notation, the smallest number, we actually never reach it because x is less than negative 11/7. Largest number possible is infinitely close to negative 7, so that's why I use a parentheses. If it said this, I'd use a bracket, right?